Hi guys, today we're going to be discussing ionic bonds. So ionic bonds are going to be formed between metals and non-metals. And they're going to be a result of electrostatic forces of attraction between oppositely charged ions. So in this case, you're going to have cations and anions. So cations are usually formed by metals and anions are formed by non-metals. And you can also have complex ions like sulfate and nitrate ions, but we're not going to be talking about the dot and cross diagrams for those. So now we're going to look at the dot and cross diagram. So if you write down this simple O-level electronic configuration for sodium and for chlorine, this is what you're going to get. So in this case, you can tell that sodium needs to lose one electron to achieve a noble gas electronic configuration, and chlorine needs to gain one electron. So in this case, that's what's going to happen. So this is going to lose an electron. And that same electron will be gained by the chlorine. So since sodium has lost an electron, it's going to be positively charged. So this is going to be the cation. And since chlorine has gained an electron, it's going to be negatively charged. So this is going to be the anion. So in this case, both of them are going to attract each other, and these forces are going to be called electrostatic forces of attraction. So now we're going to be looking at calcium oxide. This is going to form NaCl over here. So in this case, if you write down the electronic configuration for calcium, you can tell that it needs to lose 2 electrons to form a noble gas electronic configuration. And if you write down the electronic configuration for oxygen, you can tell that it needs to gain 2 electrons. So over here, calcium is going to lose 2 electrons. And you can see over here that these 2 electrons are going to be gained by the oxygen. So this is going to form calcium oxide. Now we're going to be looking at the dot and cross diagrams for some other compounds. So the first one that we're going to be looking at is Al2O3. So if we examine the electronic configuration of aluminum, we can see that aluminum needs to lose 3 electrons to attain a noble gas electronic configuration. And if we look at the electronic configuration for oxygen, we can see that it needs to gain 2 electrons. So in this case, 2 atoms of aluminum are going to lose 6 electrons in total, and 3 atoms of oxygen are going to gain those 6 electrons. So in this case, we're going to have Al2O3, and the number of electrons that are gained by oxygen are going to be equal to the number of electrons that are lost by aluminum. So the next molecule that we're going to be looking at is Li3N, which is lithium nitride. So if we look at the electronic configuration for lithium, we can see that it needs to lose 1 electron to attain a noble gas electronic configuration. And if we look at the electronic configuration for nitrogen, we can see that it needs to gain 3 electrons. So 3 atoms are going to lose a total of 3 electrons. And those 3 electrons are shown by the dots, and those are going to be gained by 1 atom of nitrogen. So the next compound that we have is MgBr2. So in this case, as you can see, 1 atom of bromine needs to gain 1 electron to attain a noble gas electronic configuration, and 1 atom of magnesium needs to lose 2 electrons. So in this case, you're going to have 2 atoms of bromine that are going to gain the 2 electrons that are provided by 1 atom of magnesium. So as you can see, the valencies get crossed. So in this case, it's Al3 plus and O2 minus. So we have Al2O3. So the valencies get crossed in this case for all of them.